Assalamualaikum warahmatullahi wabarakatuh. My name is Mimi Zarina binti Muhammad Zakri. I'll be presenting on the process selection and scoring method of our product, which is benzene. As we all know, there are a lot of process to produce our product benzene. However, we are only focused on these three processes, which are hydrodealkylation, HDA of toluene, transalkylation, and disproportionation of toluene, which are TADP, and lastly, the catalytic reforming. This three process is the process that we have chosen to doing scoring method to choose the best process to produce our product benzene. Now let's see which now let's see what is the criteria of this process selection for producing our benzene. Okay, first of all, we focus on the process background, raw material, and catalyst of these three processes. As we all know, HDA of toluene is the traditional method of manufacturing benzene from the distillation of light oils produced during the manufacturing of coke. While for the TADP, it is more complex feed and product streams and challenging operational characteristics both in the reactor and separator section than in HDA. The catalytic reforming is a chemical process that breaks down the molecule of low octane rating naphtha into high octane gasoline blending component. Now let's look at the raw material of this process. Both HDA and TADP need three raw material that are important to produce the benzene, which are pure toluene, hydrogen, and 5% of methane, while for TADP, it needs toluene, A9 or A10, and hydrogen. For catalytic reforming, two raw material is only needed, which are naphtha or gasoline fraction and hydrogen. Catalyst also one of the important criteria in choosing the process, which HDA is the reaction that can take place by pure thermal mechanism or in the presence of suitable catalysts such as chromium, molybdenum, and platinum catalyst support on silica or aluminum oxide. The catalytic process has the advantage of lower heat loads, but they have catalyst cost. While for TADP and catalytic reforming, they only need zeolite for TADP and platinum chloride or rhenium chloride for catalytic reforming. Okay, next, the criteria that we focus on is the type of reactor, product yield, byproduct, reaction condition, and cost. The type of reactor is also important for each process, which the HDA need adiabatic plug flow reactor, the ADP need gas phase reactor, and catalytic reforming need fixed bed reactor. The product that will be produced by this process is of course our product, which are benzene. HDA produce benzene, TADP produce benzene, xylene, and catalytic reforming produce reformate benzene. The byproduct is also important in each process, which are HDA produce methane and heavy impurities, mainly diphonyl. TADP produce aromatic with 10 carbons, A10 disproportionation xylene, light gases, the alkylation of alkyl benzene. And lastly, catalytic reforming produce a lot of byproduct, which are methane, ethane, propane, butane, and small amount of hydrogen. The reaction condition of each process is where we need to take note a lot, as it is important for us to understand each process reaction condition. The temperature for hydroalkylation of toluene is in the range of 620 degrees C to 700 degrees C. The pressure is at 30 to 35 bar, while for the transalkylation and disproportionation of toluene, the temperature needed is 697 degrees C with the pressure 61 bar. The catalytic reforming is the lowest temperature needed, which are 425 degrees C to 530 degrees C with pressure 7 to 35 bar. The cost needed to produce the product is one of the most important criteria, as we need to consider the cost to produce the benzene, as we need to make sure that we use low cost process. HDA is cheaper if it's not using any catalyst, as the reaction can take place by a purely thermal mechanism or in the presence of suitable catalyst. For the ADP, it is costly because of the use of catalyst. Besides, the process also presents more complex feed and product streams and challenging operational characteristics both in the reactor and separator section. The catalytic reforming also one of the most costly because of the presence of catalyst. A semi-catalyst regeneration process typically consists of 3 or 4 reactors in series in a fixed back catalyst system and operate within a timeline where the catalyst get deactivated. A cycle length and it is regenerated. The total number of 3 or 4 reactors make the production more costly. To compare these 3 process, the HDA is the cheapest among these 3 process, while the TADP and catalytic is the most costly process to produce our product benzene. Okay, lastly, we look at the feasibility by using technical evaluation or economic evaluation of each process. For HDA, the recycled gas contribute to the safety of the operation. The thermal efficiency of the plant was improved through a heat exchanger network design and heat integration. The significant decrease in utility and fuel gas consumption were fulfilled through heat integration and by utilizing the flue gas as a fuel in the furnace. For the ADP, the process presents more complex feed and product streams and challenging operational characteristics, both in the reactor and separator section. In some current catalytic system, even the benzene acetylene ratio is decreased when the demand of silane is higher. Lastly, the feasibility of the catalytic reforming is the continuous catalyst regeneration reformers are the most modern type of catalytic reformer. They utilize continuous in situ regeneration of a portion of the catalyst in a special regenerator and the continuous addition of this regenerated catalyst to the reactor. Hydrogen is a valuable byproduct of catalytic naphtha reforming process. It is also should be mentioned that according to the problem induced by the energy crisis and global warming, hydrogen has the potential to revolutionize transportation and possibility our entire energy system. This is the end of our comparing of our 3 process to produce benzene. Now, let's look at the scoring method that we have made. The scoring method is done to select a desired process for the production of benzene according to several criteria and weightage given of each of process. The table here shows that the weightage for concept scoring, which are for the availability of raw material, it is weightage on 25%. For reaction condition, product yield is high, and production cost, the weightage is on 10%, 25%, and 25% also for production cost. Lastly, for the feasibility of study, the weightage is 15%. The table here also show the rating for the concept scoring, which we rate from 1 to 5, which 1 for much worse than reference, second worse than reference, third same as reference, fourth better than reference, and lastly fifth much better than reference. Now let us see the table of the scoring method that have done by us. As you can see here, the 3 process are listed here, which are hydrodealkylation of toluene, transalkylation, and disproportionation of toluene, and lastly catalytic reforming. Here you can see that HDA was scored 3, and for the ADP and catalytic reforming also it is scored 3. These 3 process are scored 3 for availability of raw material. As all these 3 process need raw material that are easy to be found. Next, the reaction condition. Both HDA and TADP rate was scored 4, while for the catalytic reforming is scored 3. This is because HDA and transalkylation and disproportion of toluene need the simple reaction condition, while for the catalytic reforming it is a bit complex from HDA and TADP. Next, the product yield is high. As I said before, we need to make sure that the product yield of our product from the process need to be high, as we need to have the highest impurity of benzene as our product. As you can see from the table of concept scoring, HDA was rate 5, which are the best process where it produced the highest yield, while for the TADP and catalytic reforming, it was scored 4 and 3, because these 2 process these two processes only produce a bit lower percentage from HDA. Next, the production cost. As mentioned, production cost of each process is one of the important criteria that need to be looked. HDA was rate 4, while the other two, TADP and catalytic reforming, is rate 3. Because HDA was the cheapest cost if there is no catalyst used, while for the TADP and catalytic reforming, both of these process need catalyst to make sure that the product can be produced. Last but not least, the feasibility of study of each process. HDA was scored for, which HDA is the best feasibility of study process. Then TADP and catalytic reforming, which was scored 2 and 3. Okay, from the table that have been made here, you can see that the total marks for the total score for all this process is for HDA, the total is 440, and for TADP and catalytic reforming, the score is 200, 320 and 300. From this table, it shows that HDA is ranked first as the best process for producing benzene, while TADP is ranked second, and lastly, catalytic reforming, which is on the third place. From this table of the concept scoring, we can see that HDA is the best process that we will choose as our process to produce our product benzene. Okay. Okay, that's all from me. Thank you for listening.
Okay, Assalamualaikum. My name is Muhammad Asif Sofi, and I will present about the process description of the benzene production. So, the main reaction of this process is toluene and hydrogen as the raw material, and it will react and form the benzene and methane as a side product. This reaction is in exothermic, and the temperature is about 25 degrees Celsius, and the pressure is 1 bar, and the reaction is occur in gas phase. The thermal effect is about 9.98 kilocalorie per mole, where at 35 bar and 630 degrees Celsius, this amount is about to 12.1 kilocalorie per mole. There are two types of reaction can take place in this reaction. First is purely thermal THDA mechanism, or second is the presence of switchable catalysts such as chromium, molybdenum, and platinum. So in THDA process, the temperature is about 620 to 700 degrees Celsius, and the pressure is about 30 to 35 bar pressure. However, the temperature can be lowered by 50 to 60 degrees Celsius with presence of catalyst. To prevent coke formation, the technology requires high hydrogen gas exists at the reactor inlet at a constant molar with ratio hydrogen 5 over 1 toluene. The raw materials are pure toluene and hydrogen with present 5% methane. The benzene product purity should exceed 99.5%. So this is the PID of the process. First of all, the raw material, the fresh raw material, hydrogen and toluene will mix with recycled gas and recycled toluene in the mixture. Then they will be heat up in the feed effluent heat exchanger and furnace. Then they will react. The reaction begin in the plug flow reactor in adiabatic reaction. After that, they will be cooled in the simple flash. The temperature will be cooled at around 30 to 33 degrees Celsius. So they have to stream with first is the upstream, which is the vapor, and then the bottom stream is the liquid form. So the upper stream will go to purge. The function is to prevent the accumulation of the methane and to eliminate the gas. So in the liquid stream, it contains benzene and toluene, and also the heavy impurities like diphenyl. At the first column, the gases component are removed as light. This is followed by the suppression of the benzene product in the distillation column C2. On the top final column C3, it separates the unreacted toluene for recycling, while in the bottom, the heavy score diphenyl will be carried out. For the separation of the liquid mixture, it can equally be done in sequence of two columns. Stabilizer plus benzene, top distillation, will side stream for toluene recycling and heavy in bottom. The presence of two recycle provide an optimum for conversion of toluene. Higher conversion will lower the expense of gas recycling, but will increase the cost of separation. Because of the further byproduct and impurities. In analysis of optimization, found that the optimal conversion is about 70%. So that's all from me. Thank you.
Assalamualaikum and a very good afternoon. Uh, my name is Ras Azra Hisham and today I will present about safety data sheet. As you all know, our group is supposed to produce benzene. Okay, there are three ways to produce benzene, which are hydroalkylation of toluene, transalkyli- transalkylation and disproportionation of toluene, and catalytic reforming. Okay, after comparison of all these process, we have chosen hydroalkylation of toluene. Okay, the raw materials include pure toluene, hydrogen, and 5% methane, and the product is 95% benzene, methane, and mainly diphenyl. Okay, firstly, I will present about toluene according to safety data sheet. Okay, according to safety data sheet, the hazard statement states that toluene cause eye irritation and skin irritation. Besides that, it also cause damage to organ through prolonged exposure. Besides that, it is also a very high flammable liquid and vapor, and it is also may be fatal if swallowed and enter airways. Okay, after that is about the precaution. Okay, firstly, the precaution is needs to keep away from heat, spark, open flames, hot surface, and no smoking near it. Besides that, we can only use non-sparking tools. Okay, after that, we have to make sure that we use explosive-proof electrical, ventilating, and lighting equipment. Okay, after that, we have to wash thoroughly after handling it. Okay, if contact on skin, we need to remove and take off immediately the contaminated clothing. Okay, after that we need to rinse skin with water or shower. After that, if toluene is inhaled, we have to remove the victim to fresh air and keep at rest in a position comfortable for breathing. Okay, after that I will explain about hazard category. Okay, this toluene is categorized as flammable liquid. After that, it also causes serious eye damage and eye irritation. Thirdly, is toxic to reproduction. And after that, in a single exposure, it can destroy central nervous system. And if repeated exposure, it will also destroy central nervous system, kidneys, and liver. Okay, after that, it's about hydrogen. Okay, the hazard statement states that the hydrogen can form explosive mixture with air. Besides that, it is also flammable high pressure gas. After that, it burns with invisible flame. Okay, hydrogen also is stated that may cause dizziness and drowsiness. It can also ignite if valve is open to air. Okay, the precaution of hydrogen is first, we have to keep away from heat, sparks, open flames, and hot surfaces, and especially no smoking near hydrogen. Okay, after that, we have to protect from sunlight when ambient temperature exceeds 52 degrees C. Okay, after that, we have to keep container tightly closed. Okay, besides that, we cannot and do not breathe dust, fume, gas, mist, vapor, or spray, and do not get in eyes, on skin, and on clothing. Okay, we always have to wear protective gloves, protective clothing, and eye protection, face protection, and respiratory protection when handling hydrogen. Okay, if inhaled, we have to remove victim to fresh air and keep at rest in a comfortable position for breathing. If breathing still is bad, we have to contact the physician. Okay, besides that, if contact with eyes, we have to rinse continuously with water for 15 minutes, hold the eyelids open and away from the eyeballs to ensure that all surfaces are flushed thoroughly. Okay, if it goes more bad, you have to contact an ophthalmologist immediately. Okay, the hazard category for hydrogen is acute toxicity. Secondly is fatal if inhaled. Okay, it can also may cause respiratory irritation. Okay, after that is benzene. Okay, benzene is the product uh, of this uh, plant. Okay, first is the hazard statement. Firstly, it is extremely flammable liquid and vapor. It can also cause skin irritation and suspected of causing genetic defects. Besides that, it can also cause cancer and cause damage to organs through prolonged or repeated exposure. It can also may be fatal if swallowed and enter airways. Okay, the precaution of benzene is you have to keep away from heat, sparks, open flame, and hot surface. Besides that, you have to wear protective gloves, protective clothing, eye protection, face protection. After that, you have to only use outdoors or in well ventilated area. Okay, besides that, you have to take precautionary measure against static discharge, and you have to wash thoroughly after handling. Wash your hand thoroughly after handling. Okay, if inhaled, you have to remove victim to fresh air and keep at rest in a position comfortable for breathing. Besides that, if contact with skin, you have to wash with plenty of soap and water. You have to take off contaminated clothing and wash before reuse. Okay, if skin irritation occurs, seek medical advice. Okay, besides that, if it is in contact with eyes, you have to rinse cautiously with water for several minutes. Then, if you're wearing contact lenses, remove it. Okay, if eye irritation persists, get medical advice and attention. Okay, the hazard category for benzene is first is flammable liquid, second is acute toxicity, third is germ cell mutagenicity. It is also carcinogenicity and toxic to reproduction. Okay, the fourth one is methane. Okay, the hazard statement shows that methane may form explosive mixture with air. Besides that, it contains gas under pressure. It may explode if heated and may displace oxygen and cause rapid suffocation. And lastly is extremely flammable gas. Okay, the precaution of methane. Firstly, we do not handle until all safety precautions have been read and understood. Second is you have to use and store only outdoors or in a well ventilated place. You have to keep away from heat, sparks, open flames, hot surface, and especially no smoking near it. If there is a leaking gas fire, do not extinguish unless leak can be stopped safely. Okay, besides that, we need to use a backflow preventative device in the piping and eliminate all ignition source if safe to do so. Okay, lastly, use only with equipment rated for cylindrical pressure. Okay, if methane is inhaled, we have to remove to fresh air and keep at rest in a position comfortable for breathing. If not breathing, give artificial respiration. Okay, besides that, if contact with eyes, immediately flush eyes through thoroughly with water for at least 15 minutes. Hold the eyelid open and away from the eyeball to ensure that all surfaces are flushed thoroughly. Okay, the hazard category for methane is firstly is a flammable gas, is also acute and chronic toxicity. Third is also compressed gas. Okay, lastly is about biphenyl. Biphenyl is the byproduct of this process. Okay, the hazard statement. Firstly, biphenyl causes serious eye irritation. It also may cause respiratory irritation and also may be harmful if swallowed. Okay, it is very toxic to aquatic life, so cannot release it to the ocean. Yeah, okay, the precaution of biphenyl is firstly you have to avoid breathing dust, fume, gas, mist, vapor, spray of biphenyl. Secondly, avoid release to the environment. Thirdly, is causes eye irritation. Okay, if contact with skin, we have to wash it off with soap and plenty of water. If it continues to irritate, consult a physician. Then, if it's inhaled, move the person to fresh air. If not breathing, we have to give artificial respiration and also contact a physician. Okay, the hazard category for biphenyl is firstly is acute toxicity, second is reproductive toxicity, and carcinogenicity because it causes cancer also. Okay, this is all the raw materials and product and byproducts of our process, and this is all in the safety data sheets. Okay, that is all for me today. Thank you and have a great day.
Assalamualaikum. My name is Muhammad Abdul. I will explain on the hazard and operability and basis of the production of benzene. So, what is hazard? Hazard is a structure and systematic technique for system examination and risk management. In particular, hazard is often used as a technique for identifying potential hazard in a system and identifying operability problems likely to lead to non-performing products. Hazard is best suited for assessing hazards in facilities, equipment, and processes, and is capable of assessing systems from multiple perspectives, such as design and assessing system design capability to meet user specification and safety hazards. Other than that, it is capable for physical and operational environment, which assessing environment to ensure system is appropriately situated, supported, serviced, contained, and so on. Furthermore, it is capable for operational and procedural control, where it assessing engineer control, sequence of operation, procedural control. It also assessing different operational modes such as startup, standby, normal operation, steady and unsteady states, and many more. Next, I have choose 5 study notes which are compressor K101, furnace F101, reactor R101, flash drum V101, and distillation column E102. Let's see first on the compressor K101. For study note compressor K101, the process parameter is a pressure. And for the high currents, the process can be more pressure in the reactor and also the compression control failure. And for its consequences, the pump and mixer hard to adequate with the liquids and gases. And for the action required, it needs a trigger automatic emergency shutdown and also use a fail open or fail close valve. For the low pressure, it can cause valve opening malfunction and leakage in the piping system. As for its consequences, the hydrogen gas cannot be recycled and inconsistent initial concentration. Last but not least, for the action required, we need to check up on the valve and maintain the control pressure. Next is for the study notes furnace F101. The process parameter is the temperature. For high temperature, the causes can be failure in opening the inflow valve of the furnace. As for its sequences, the valve has to be closed and for it to keep adequate the temperature. And for the required action, it provides the valve with a system to prevent it from complete opening. For a low temperature, it can cause failure in locking the inflow valve of the furnace, and also insufficient of the amount of supply reactant. For the consequences, the temperature of the lines can be decreased and the rate and duration can be at the low rates. Last but not least, for the action requirement, we can add a device to prevent the valve from a complete closing, and also we can do a regular inspection and maintenance. For the third study notes, it is reactor R101. The process parameter is flow. For high flow, it can cause cooling flow increase and also the control valve is fully open. As for its consequences, there will be the existence of runway of heating and the action react should be we should installation of flow control. For a low flow, the process can be the control valve malfunction, and second one, it can be blockage in the piping system. For its consequences, there will be low in the production of benzene, and also it can reduce the duration of the production. So, the required action should be proper maintenance and operator alert, and also we can isolate the water source. For the no flow, which there's no flow, the causes can be the cooler valve will be malfunction, and there will be leakage on the feed line. So for its consequences, the temperature increase in the reactor, and also there will be no production of benzene. So what should we do is take action and install the high temperature alarm, and also check the maintenance procedure. For the fault study notes is flash drum V101. For its process parameter, it is level of process parameter. For high level, it can cause two core in the inlet stream and also the blockage in the vapor stream. So the consequences is there will be no explosion occur, and also there will be risk on the drum explosion. So what should we do is install the temperature controller at the feed, and also install the pressure alarm. On the low level, the process can be too hot in the inlet stream, and also the blockage in the inlet stream. So for the consequences, the power will might be damaged, and also the valve will be closed. So what should we do is required action is install a low level alarm or install a valve. Last but not least, for the product column, or we call this as installation column P102. The process parameter is level. For high level, the process can be the blockage in the output and the control valve failure. So for the consequences, the distillation column can be exploded, and also the column can be flooded. So what should we do is we install a high level alarm and check the maintenance schedule. For a low level, it can cause a pipe pressure clog or leakage in the piping system. So the consequences is the valve will be closed, and also the net flow of the material. So what should we do is install a low level alarms and monitor the distillation column and level control system. So for the distillation column on the process parameter pressure, for its high pressure, the causes can be high pressure stress on pipe. So the consequences can be distillation column might be damaged, and the desired product cannot be produced. So what can we do is use a better material for the column and regularly maintain the distillation column. For the low pressure, it can cause high pressure pump malfunction and also leakage in the pipeline. So its consequences can be inadequate steam for the process and also backflow of the product. So what can we do is install a low pressure pump and also regular inspection and maintenance. Last but not least, for the distillation problem, under process parameter temperature, on high temperature, it can cause low flow rates and also overheating might occur. So its consequences can be the quality of the product will be reduced, and also the distillation process accelerate. So what can we do is we install a high temperature alarm and check the maintenance procedure and schedule. For low temperature, the causes can be the flow rate might be high, and also the heating cannot be processed. So for the consequences, the process might be delayed, and maybe there will no distillation take place. So what can we do is required action is install the low temperature alarm and also check and monitor the distillation column and temperature control system regularly. I think that's all for me. Thank you.
Hi, my name is Muhammad Amin Marabi Muhammad Subri, and today I'm going to present to you about the hazard identification, risk assessment, and risk control on the proposed process, which is the HIROC, and also the fault tree analysis, which is the FTA. So the purpose of hierarchy is actually to identify all the factors that may cause harm to the employee and the environment, and to consider what are the chances of it to happening, and to enable the employer to plan and introduce a preventive measure to counter the problems. So in this hierarchy, we'll use the formula of risk equals to likelihood times severity. So likelihood is the possibility of an event to happen, and severity is the outcome from the event, whether it's an injury to the person or injury to the environment, damage to the environment. So from the likelihood, we have this one likelihood rating table. You can see like the most likely to happen will give the rating of 5, and the most unlikely to happen will give the rating of 1. For the severity table, if the event can cause catastrophic with numerous fatalities, irrecoverable property damage and productivity, we give the rating of 5. And if it's negligible, such as minor abrasion, cut, and first aid type injury, we give the rating of 1. So this is the outcome, this is the risk table, which is the outcome from the severity times likelihood rating table. The red zone indicates that the plan requires an instant action for us to counter this problem, while for the medium, the yellow zone indicates it's a medium problem, which indicates that it requires a monitoring and also reporting. While for the green zone, we can exercise precaution and training to counter the problems. So all these guidelines are obtained from the Department of Occupational Safety and Health Malaysia 2008. For our plan, we managed to identify around 7 hazard identification, and this is the list of it. So as you can see, for the hazard identification, we have the work activities, whether it can happen. We can identify like whether it's a manpower problem, property problem, environmental problem, event problem, mechanical problem. And then for the hazard, we can detect what kind of hazard that the work activity can cause. And the cause is the effect of the hazard to the environment, and also to the environment, property, and also to the manpower. So from that, we proceed to the risk analysis, which is we identify, do we have any existing risk control to prevent this problem? If none, then we proceed to the likelihood, severity, and then we time those two between the likelihood and severity using the likelihood and severity rating table, and we'll get a risk assessment. From the risk assessment, we can know like what if the recommended control measure, what kind of recommended control measure that we need to implement. So from the list over here, you can see that from item number 1 to item number 5, there's only a low risk work hazard identification, which we already recommended all kind of practice and exercise that need to be implemented. For the item number 6 and 7, which is a mechanical hazard identification, the risk reached to a medium level, which is number 12 and number 15. So from that, it requires for us to adjust the process for the process plan layout, which is we need to apply a feedback control system operator to apply a feedback control system for the operator to be more alert if the equipment leaps over and jam, because this kind of equipment can cause fatalities or irrecoverable damage to the property or environment. So next we proceed to the fault tree analysis, which is to identify and analyze factors that may contribute to an event, and also the effect of the factors, which we produce it in using a tree diagram. So this is the steps on how we do it, which is we define the system, define the top event, define the tree top structure, explore each branch, solve the fault tree analysis, and identify important dependent failure potential, perform quantitative analysis, and also use the result in decision making. So from our process plant, the event or top event was the vessel explosion. So from the vessel explosion, if pressure measurement, so the vessel explosion will happen if pressure measurement failure and operator does not stop flow. With those contributing to event, it will contribute to a vessel explosion. For the first one, if the pressure measurement failure, it's either caused by failure of control valve or failure of pressure alarm. For the second event, which is operator does not stop flow, it can be caused by the failure of control valve or operator does not aware of high level. If the operator does not aware of the high level, it's is the combination of event from the level indication of failure and so high level alarm failure. Level indicator of failure, which is the result of either level measurement fail or level alarm fail, while the high level alarm failure is contributed by the level measurement fail or alarm indicator fail. So from the FTA analysis, this is the calculation that we can do about we can calculate from it, and from this analysis we can know like the possibilities of the failure to happen is in it's going to happen once in a 3.236 years, which is this can which this is can be like a guideline for us to be more careful and precautious uh, in monitoring our process plan. So that's all for me. Thank you very much.